we've got backsplash tile, perfect horizontal lines, but we've got uneven floors. So we've had the general contractor and homeowner walkthrough. It's been about 15 minutes identifying the circuits in this space, so everything's de-energized and it's safe to work. That's exactly where you start. Second, Tim and Cliff, my help today, are taking everything down to basic components. Nothing in this kitchen is right and nothing is where it needs to be. I'm gonna spend about 45 minutes on the layout process. We've got can lights overhead, we've got under cabinet lighting, 2 pendants, receptacle outlets on the countertops to code, and appliance power. Once that's complete, we'll spend the remainder of the day pulling wire and making terminations, as well as a couple accessory components for the homeowner throughout the house. Let's take a look at the tools and materials. We've got 2 other videos that you can click on here about basic electrical tools and 3 essential tools before starting any project. I've got my basic electrical tools and they're in a pouch, so that's gonna make it real convenient for me to execute on my work. I really like this NM cable stripper. Man, this thing's absolute gold. It's gonna do a nice, clean, professional job for you. So check that baby out. Of course, I've got a drill, a driver, work light. I've got more work light, and you just can't have too much work light, especially when you're in these dark, old basements. This baby, when I'm fishing wire, is fantastic. This triple hinging needle nose pliers, that's just gonna facilitate my reach down inside the wall. Really love that guy. I've got bits to go with drill and driver, as well as self-feeding auger bits. Man, you just can't overstate the value of that self-feeding tip and how it's gonna pull through the work with ease. Of course, I've got an oscillator for cutting the finished surfaces. I just store the blade like that. That's not how I cut. I'm gonna inspect the panel, and every time I pull a panel cover off, I really wanna be taking a look to see if anything's heating up like it shouldn't be. I've got a boroscope for inspecting inside walls in case there are any concerns. I've actually got an MC cable stripper, and that's gonna work on my BX in this older home. This is a 1940 home, so I'm gonna encounter some steel armored cable. That's gonna allow me to address that with ease. Of course, I've got a hammer, fiberglass handle. I've got a drywall saw, fish sticks, a tester, a multimeter, a plug-in tester. Always want to verify work when complete. A folding rule, you guys know how much I already love this. Tape measure, Sharpie, pencil. Let me state right here real quick. Never, ever, ever Sharpie on finished wall surfaces that aren't going to be covered by a tile backsplash. It will bleed through the kills. Coat 1, kills coat 2, kills coat 3, you're gonna have a grumpy general contractor, so that can only be used in concealed areas. I've got a fire caulk gun for dispensing my fire caulk, ear protection, a long exploratory bit. When I'm drilling into the unknown, I can do it a little bit more cautiously and discreetly, and of course, my old bump cap to protect my head and hat to keep dust out of the eyes, as well as safety glasses and hand protection. This about covers it. If I use anything else, I'll fill you in on the deets. If you're a DIYer doing this project, you're not gonna have an infinite budget for Pro Tools. I would probably exclude the $300 thermal imager. Can find cheaper versions. I might exclude the $100 boroscope, but I'm telling you what, you probably don't wanna exclude the $15 Romex strippers, the $25 Klein test equipment, the self-feeding auger bits. You can get small packs, 2, 3 of those at a time, and the oscillator. This has got to be one of the top tools, especially for older homes when you're cutting through plaster, wood. Man, this baby is gonna save you time. The last tool I cannot forget to tell you about is the laser level. We've got a $300 version on a Milwaukee tripod. You can do it for a heck of a lot less, probably 50 bucks. But the reason a laser is so important, we've got backsplash tile, perfect horizontal lines, but we've got uneven floors. So in utilizing the laser, we can get the receptacle boxes plus minus 1/16 of an inch. We've got the rest of the ability to adapt up and down in the receptacle yoke itself. That play is built into it. So we can dial this in with perfection to the perfect horizontal lines of the brand new beautiful tile and come out with fantastic results. This is also going to serve to dial in our can lights quickly without having to measure off the uneven walls. So in every kitchen, this is pretty much going to be the basic set of materials that you're probably going to utilize. We've got our wire, our 14-2 and our 14-3 and 12-2. These are the 3 basics. We're going to use all of them today. You might also notice we've got this 18-2 low voltage wire. This is for our DC low voltage under cabinet lighting. In addition, we've got fire barrier sealant. That is going to be used to seal every vertical penetration according to code. Fire caulk is designed to resist smoke and fire and prevent the passage of it throughout the house. We got 4-inch new construction can lights. Some of y'all love your wafers. I pretty much still like my can lights, pretty darn good. 3-gang boxes, as well as nail plates and wire connectors. You might notice we have a variety of boxes. I always like to bring a variety of boxes. This is a screw through the side box, is what we call it, right? There's probably a better name for it. Drop that in the comments if you know what that is. I actually don't know off the top of my head, but I love those boxes. Adjustable boxes, these things are absolutely golden for backsplashes because you can just reverse that screw and pull it out to match the face of the finished material. We've got those come in 1-gang and 2-gang. We've got 2-gang remodel, 1-gang remodel, 2-gang nail on, remodel, and new work light boxes. I wasn't apprised of the finished surfaces in this space, whether the walls were up or down, so I brought a whole box of boxes to accommodate every scenario. Also have a saddle pancake box. This is a high capacity pancake box. Standard pancake box, a GFCI, it's a used and crusty old GFCI for temporary power. This is a construction lighting pigtail. So we can wire this into one of the pendants, for instance, and provide temporary construction power in a safe manner. I've also got a couple of light bulbs to throw in my can lights. I want this place to be well lit. That's going to convert to high quality work. We've got a couple of breakers. We're going to be adding at least 3 20-amp circuits to this kitchen space, as well as potentially a dedicated lighting circuit. Because I'm a pro, I've got my stuff box here. So I've got 1-inch drywall screws. I've got wire connectors of all types. The green ones here for grounding connections, electrical tape for wrapping devices and identifying conductors. I've got additional wire connectors. Of course, you can't forget your staples to secure conductors and cables within 18 inches along the length of the wire to the box. The range is very typical that it will provide a grade area, that's a real awkward shape on this one, that's permissible to place the outlet and the gas. So we need to be pretty detailed in our layout of the wall to make sure that the receptacle outlet is within that space and avoids the gas connection, which has already been installed. It's going to be more lucid at a later date when you see all the cabinets and countertops in place, but you got to know right now that every kitchen countertop must be, that's over 12 inches in width, must be serviced by a receptacle outlet. So we've got a receptacle outlet in this 12-inch countertop, then we've got a 30-inch range, which is standard, and then another 12-inch countertop. So we're gonna have 2 on this wall, plus 1 for the range, plus 1 for the refrigerator. Refrigerators can often be in the same boat where there is a specified area that's permitted for the receptacle outlet. However, it's common for those to be right angle and pretty flat to the wall and not obstruct the fridge. But you do have to know what appliances are being purchased. You've got to have the spec sheets and you've got to dial into the approved zone. Or when that range goes to slide back in there on the finish out, boom, boom, it's going to come up 3/4 of an inch shy. It's going to be sticking out. It's going to look bad, and you're going to be back here on your hands and knees with the range out, husband and wife standing right there looking at you as you cut into their brand new kitchen to rework something that wasn't right the first time. Converting fractions to decimals and using a calculator that shows your work so you can verify that your math is right and your dimensions are dialed in, and then even taking pictures to document all your rough-in work according to the plan sets, so everything's documented, because in a kitchen remodel there's quite a bit of complexity and there's a lot of room for things to change and the communication not to get all the way back to the electrician, and you've got to be able to prove on every single thing. If you're working with a contractor that's a little bit argumentative, which thankfully I'm not, you've got to be able to prove that your stuff was in the right spot, because these plans will go through 3 or 4 iterations a lot of times, and you may not have been handed the right set of plans or the final set of plans. And so you've got to be very detailed, you've got to document, and then you've also got to be willing to give a little bit towards relationships that are meaningful and important. Okay, I'm going to stubble wire there, about 12 inches out of the wall, maybe even 18. I'm going to cap it off, and that is going to hardwire right back into the back right corner of the range hood. Range hood is sitting right here. That range hood is both top wire and back wire compatible. Utilizing company cam to take photos of what is. I like that wide angle camera. It's so valuable for capturing big swaths of information. You never know when you're going to need one of these pictures to see the stud layout.
Okay, now we're in the basement below the kitchen. This is the electrical panel that we've ran our new home run to, that we're running to the range. We haven't stapled yet, but this is the home run going into the outlet, which is about 18 inches above that bottom plate. I'm now going to run a wire from that location across these two joists, drilling through them, and then through the bottom plate here to the fridge, and that'll be one circuit for the fridge for the kitchen that we're running today. So I'll cut this at the bottom of the panel. And label this, because we will be running probably 2 more home runs, so that we know, so that we can label the panel cover appropriately at the end of the job. And once we get all the home runs ran, we'll get them into the panel all at the same time, instead of spending time doing each one as we run them. Hey Tim, are you ready for me to push this wire to you? Make sure to go above these wires and not underneath, so that when we staple it'll look nice. Of course, I moved these boxes back in my way.
Ready? Are you pushing on the fridge side or the other side?
The range. You need to pull all the slack. I'm not going to leave the slack down here. Okay. I'll staple this after we have all the wire ran, so I can staple everything at once. So we're right above the basement where I was pulling the new home run and hot pass or extra wire for the range and fridge. This is the wire that I just ran that runs down into the basement, across to joist bays, and then up into the wall over here. And we'll put an outlet in the classroom lab there. And this is the home run that I had ran previously.
Is a separate, that makes 2. Dishwasher disposal, separate, that makes 3. That wall, 4. Countertop there, 4. Appliances, 5. Countertop, 6. It's quite a bit.
6, yeah, that's kind of a lot. I don't think we have room for that many.
Do you know what our max count is in there?
I've taken 1 out. I think there might be 1 or 2 more extras. We might have taken, yeah, we're taking 1 more out there. So I think we're at like maybe 4 without putting space savers in.
Well, we do have some space savers.
But I'm not sure, I haven't looked to see if the panel accepts those.
So in an ideal world, we would have a total of 6 circuits in this kitchen. Code is a minimum of 2 dedicated 20 amp small appliance branch circuits that serve all the receptacle outlets contained in the kitchen, pantry, dining room, breakfast room, and other such similar spaces. Here in the kitchen alone, we'd like to have 6. 1 for the appliances on that wall. That's the range hood, the gas range, and the refrigerator. Some people are screaming and always make the fridge dedicated to avoid tripping the circuit. It just hasn't been my experience. 2 countertop receptacles that wall. 3 countertop receptacles this wall. 4 countertop receptacles this wall. 5 dedicated for the micro, because that's 1500 watts plus. And 6 dishwasher disposal on a circuit. So 6 is nice, but let's see what we have in the panel. It could be that we pare that down a little bit, and then he gets to expand it at a later date when we upgrade the panel, because we were finding issues, and we're going to send him an itemized estimate for all the extras that we come across. It's a courtesy, it's informative, it informs the future budget. When you treat someone like that, not scare tactics, but strictly informational, a lot of times they really value that type of communication, and you're just back knocking out that list as the budget allows. It's right there. First that. Grab another oscillator. Such it is. Hello, this is Joel.
Joel, hey, my name is...
Joe's got the patience of Job.
Oh, it's double studded. There's two studs stacked next to each other, or there's at least blocking next to this, so I can't wrap these flanges around the stud. So I'll have to flatten them out so that I can mount it properly. I'm not going to mount the box until we have the wire ran, so that we have this cavity to be able to reach in and grab the wire. We'll put it in the box and then we'll mount it. which I've cut a slit up here so that this flange can go through there. And I'll put this one behind the drywall as I go in to minimize any damage to the drywall. Then I'll screw it in. 3 being the one over here.
Yep.
So there's just 2 on this wall.
Yep.
So if we do these 2 outlets and these 2 outlets together, that eliminates 1. And then can we put the microwave and dispose it together? No, because we have the dishwasher as well. Because that would put 4 outlets on 1 circuit and 3 on, because I think you have 1 on either side of the window here and 1 over there, right?
Right. I like to strip them before they go in the box because now you can't use this. You have to use a knife. Makes sense.
Yeah.
What? Yeah, I'm struggling to give up getting it below 5. I like your recommendation.
Yeah. It's only a 100 amp panel, so it's got limited number of circuits.
Right.
Right. We're used to putting it into a 200 amp panel.
So what if we extend one, pick up 1 more, so a total of 5 outlets on that 1 circuit, still within code. These 2, pick 1 of these on the garbage disposal circuit and 1 on the appliance circuit. So essentially just took 25% of a circuit and shoved it off a couple different ways.
So this is sort of going to be a workspace over here because it's lower. So we'll probably have coffee maker or whatever higher use appliances there.
Think so?
Or I'm trying to think of where the
Let's at
most-
least put J boxes in the basement
Okay.
so that if that panel gets upgraded and we've got the additional capacity, they can have easy access to then route a new circuit back. Does that make sense? Nothing's going to be considered continuous load, so we can go full 20.
Okay.
One thing that happens with a continuous load circuit is you've got a D rate to 80%. So if you've got 12 gauge wire, 20 amp circuit, and a continuous load, your max designed for that circuit is 16 amps. However, the code defines continuous load as 3 hours or more under normal circumstances. It's Article 100 definitions, I believe. And so this is, none of these are continuous load. Typically it's like lighting, heating and cooling equipment, things of that nature. We expect them to be on for 3 hours straight, but coffee makers, dishwashers, garbage disposals, and most of all, are not on for 3 hours straight.
The home run outlet, but this is the hot pass to the next outlet.
So now Cliff and I are working together fishing wire to minimize damage to the finished surfaces. That's good. And he drilled the hole, sent the fish stick up. There's always a way to, or nearly always, to determine where you are, to locate, find reference points between up here and down there. So I'm gonna tape this on and go ahead. All the kitchen receptacle circuits are wired in 20 amp. That is code. You can use 15 amp for lighting, but you cannot put lighting on the kitchen receptacle circuit. You can do that in the bathroom, however. Bathrooms are required to have 20 amp circuits, but you can only add the lighting if that bathroom is alone, dedicated, all by itself, everything 20 amp circuit. That's the only time you can add the lighting. I like to take the twist out of the wire so it pulls through more easily. I'm going to start installing my boxes. And the countertop is right here as measured off the plans, and you've got to account ½ inch. If you're measuring off framing, then you've got to add a ½ inch because the cabinet plans are measuring off the finished wall surface. So you got to be mindful of that. That'll put you a ½ inch off if details matter. And then the first receptacle has to be within 24 inches. Oh, look at that. Boom. Within 24 inches of the edge of the countertop. And then this receptacle covers 24 inches from there. And that receptacle covers 24 inches here. So you can have up to 48 inches between receptacle outlets. So this one's gonna be here. We'll be in great shape. That one's there. We've got coverage all the way to the edge of the sink. So edge of sink, 24 inches max. 48 max between receptacles, 48 max between receptacles, 24 max to the edge of countertop. Now what you could do is install a receptacle in the outside edge of the cabinet. Let's say if you didn't have space right here. We do not have, you see our cabinet comes up, our countertop comes up to 36 inches to the top. Our box is going to be at 40, so it's going to be close. You've got to account for the dimension of the plate, the finished plate, and not just the box. So we're going to be tight squeezing it in here. We would not be able to do that if there was a countertop backsplash. However, there's only a tile backsplash that comes flush to the countertop, so we're able to squeeze those receptacles in there, and then we decided to match everywhere. Standard is 44 to bottom of receptacle off floor. We're going 40 to accommodate this obstruction and these obstructions. The fire blocks, those are at about 46, so we'd be knocking those out everywhere they appear. So we're gonna leave the fire blocks intact. We're gonna drop just below that. It's multi-purpose. This is where it's helpful, not just to know the rules of thumb, but to know the code, so you know how far you can go and still fall within the boundaries of the code.
The tip of your screwdriver, about 1 inch to the right of the gas line.
Yeah, I have to reroute the wire.
Okay, I'll leave it in there for a sec.
This conductor is not going to become energized until we finish everything out. But for the other people on the job site, if they see that, they're going to have a greater level of comfort. They'd probably even feel more comfortable if we wrapped it all with electrical tape. Not required. I am going to label the intention of this wire, and that is range hood. Every wire hanging out of the wall gets a all caps shop letter range hood. Nice and neat. And we take it, coil it up, and it's going to live right there at the designated location until that range hood is installed. Look at that. Boxes shall be securely fastened to the building structure. Now we're going to pull that out. Way out. And hopefully it'll tile up to that. We'll still be a little bit too far out. We'll come back on the finish out. We'll tighten that down and flush it up to the face of the drywall, and boom, gorgeous. So it's going to be a little bit too far out on purpose, because we want that box all the way out to the edge of the finished surface. Again, in this case, that's tile. Sometimes the wire before, because it'll hit an obstruction, will have the latitude to move one way or the other. But if the homeowner's here, it's nice to get the boxes on and be like, this is what you expected, can lights, yep. He's like, yeah, looks good. And then you wire it all up and you've got their okay, right? So if things start needing to change, they start owning some responsibility in that because they approved the locations. So box is on, homeowner walkthrough, but he's not here today. So we'll just do it as it's convenient for us.
In this case, we've got a double beam that's sitting right underneath that 2x4. And so I'm going to intentionally bring my drill to the very front edge of the stud, and then we're going to nail plate it per code to protect the wire.
So underneath this bottom plate, there's a double joist. So as opposed to drilling up and avoiding the drywall repair, we opened up the wall and drilled top down. Now, a drywall repair like this is probably only going to cost 30 bucks. But, you know, as a courtesy, if we can keep it clean, minimize repairs. It's a neater finished job. Respect the time and energy of that $30. That's a good thing. So I drilled at an angle. I probably went through just the top quarter or less of that double joist that's sitting here. Cliff's got it on the bottom. He's going to route this and put it on with a circuit on that wall. We're limited to a maximum of 4 kitchen circuits, and that panel is topped out. We can't add circuits to it without violating the listing of the panel. Where that's going.
Is that all I can take?
That is a little bit too much. If you leave me like 3 or 4 inches, I'll be good. People are always asking, what about electricity and water? And the answer is yes, absolutely fine, because it's fully contained. What is a violation, and this could vary by jurisdiction, you've got to know your local standards. But here in Indianapolis, what's a violation is to put an electrical panel underneath plumbing lines, whether drain or supply. That does need to have its own, the electrical panel needs to have its own clear space without any piping or plumbing system that could, through condensation or leakage, damage the panel. But as far as utilizing this massive plumbing hole, I'm going to do that for sure. And one thing to bear in mind is I don't want my wire to be pinched back here. Like if this was a 3-inch plumbing pipe, it would have a 3.5-inch outside diameter. That's the full depth of the stud bay. And for me to cram that wire back there puts it in jeopardy to a siding job on the exterior penetrating it, and would cause the plumbing to bulge the wall slightly when that finished wall material goes on. So I can pass through here. I'm a little surprised that the plumbers just nail plated this, because that's a window, got a jack stud and a king stud, and I'm a little surprised they didn't put a structural component on that, but that's just me. So you might be wondering about that little loop in the basement. Here we'd like to have 6 circuits in the kitchen. The panel allows for 4 max without any violations, so we're sticking to 4. We're dropping a loop down into the basement. If someone wants to intercept that at a later date and run a home run back to the panel and isolate that receptacle because it's got larger loads on it, fantastic, they can do that. That one as well, they can do that. Where it drops into the basement, jumps up over here, they've got at least 3, maybe 4 locations where a circuit can be bisected in order to increase the overall circuit capacity in the kitchen. If they're struggling with Instapots and things of that nature, that's like 1100 watt appliance, plus a coffee maker tripping out circuits, they'll have adaptability.
We're back in the basement below the kitchen, just reviewing what we've done today. We ran 1 wire from a countertop outlet over here across the basement into the fridge receptacle to get power from the fridge. We ran a home run behind this ductwork to the microwave, back to the panel. And we've ran another home run straight up this wall for the majority of the countertop outlets on this east wall. This AT&T box was secured to our wire, which is not allowed. You're not allowed to secure to other trades equipment or wiring, pipes, anything, because if I have to disconnect this, and now this is just hanging loosely in the joist bay. That's not an electrical job. That's AT&T. We'll probably end up finding some other way to get it up there, but it causes
Don't overthink it.
friction between. Yeah.
Okay. Yeah. Cool.
So never attach to plumbing or HVAC items in a basement or wherever you're at,
Got it.
so that they can service it later without.
Question for you. I know you were wondering, so was I. For NM cable, commonly called Romex, like Kleenex, it's the name brand that popularized it. For NM cable, there are two concepts, and every other type of conduit and cable, there are two concepts called securing and supporting. Similar but different. Answer in the comments below if you know if a horizontal hole bored through framing counts for securing or only for supporting. So as we've mentioned, these extendable boxes, adjustable boxes, they're key when you've got backsplash coming into play. You want to bring them out as far as possible. However, if you don't communicate with the homeowner general contractor and they're not used to seeing that, they'll be like, that looks wrong to me, and you'll get a phone call. So proactive communication on everything you can think of. It's a must. Here's the other deal. We have no ability, unless we cut more drywall, to place a staple within 12 inches of the box as required by code. The code, however, does have a provision that NM cable and other types of cable too may be fished through voids in walls, masonry, and other types of structure. So I've got a staple down here. It's fished and unsecured. I've used the exception. It's not secured within 12 inches of the box, and that's my prerogative. It's a prerogative given to me by the code. Here's another thing, you want to tuck those wires way back because crazy things will happen, right? The drywaller, the tile guy, they're going to be working here. And so if you tuck those wires very clearly back into the box, you're going to have the highest rate of success because those roto zips will snag that wire. And if it's up like this, man, they'll nick it right there and they'll shear it off and you'll have nothing left on it. And you'll have to use Wagos and splice it. Blech. So, neatly tuck everything well, inch behind the face of the box. Here's another one, right? A lot of these boxes have an in and an out, a line and a load, a hot pass coming in and going back out, feeding down the circuit. So we have the home run is here. We have another cable coming into that home run, which is here. I'm gonna clearly label this cable in the box with a piece of black tape on the black conductor, and that's our little inside language indicating that that's the home run and GFCI for this circuit. This outlet is going to have one GFCI, which is then going to feed downstream, protecting all the other outlets as required by code. So GFCI protection is required for not just the countertop outlets, but it's also required for outlets that service the countertop, right? Subject to interpretation, but generally speaking, within, I think it's 12 inches of the countertop, 12 inches of the countertop, or 18 above, they're considered to be serving the countertop. Also, receptacles within 6 feet of the sink. So this receptacle is just a temporary GFCI for construction power, but long term it's going to be for the dishwasher and disposal. However, it does not service the countertop. So just when you're thinking GFCI protection not required, you're wrong. It is within 6 feet of the sink. How is that measured? Because the sink is right here, right? You can see it. How is that measured? It's measured along the cord. So once the cabinets are installed, if you can take a 6-foot corded appliance, like a lamp, plug it into that outlet, and drop the lamp in the sink, it's within 6 feet. That's how that's measured. That's my guy, that's my guy. So I'm gonna put a flag of black tape that's real nice and visible. That's my home run GFCI right there. And then when I take my final completion photos, I'm also going to mark them up and indicate that. I'm gonna make sure I pull at least a 1/4 inch of the outer jacket into the box to protect the individual conductors. And then again, because this is my home run, I'm gonna reach into my side pouch, wire nut that in case it becomes live. Someone's flipping circuits. I'm protected. I'm going to go ahead and cap the neutral too. Tuck them back in there. And that is one complete box termination. It's solid, it's pulled out, 1/4 inch jacket, tucked, stuffed, and marked. All right, here's my hot pass to my other switch box.
Ooh, that's on the other side of the door. Stud. I'm gonna do it from above. I'm gonna do it all the rest of it from above. Disregard. All right, so now I've got a home run into my 2-gang box. I'm gonna set the box, even though it's for lighting, at the same height as the receptacles, so I've got a good uniform appearance. Remember, as soon as that horizontal tile is installed, you want everything to match up. I've labeled my home run, I've cut it and stripped it extra long on purpose so that I can make up to both devices without having to strip and terminate. It's gonna reduce the number of potential failure points. More on this video, click here. And one switch is going to be for my pendant light, which will be located right up here above the sink. Really, really common. It's a good look. Anytime you can combine 3 forms of lighting in a room, there's something magical about 3. Like, things look better in odd numbers. We're going to have our overhead can lights, our pendant lights, and I've got to get clarity regarding whether there are 2 pendants here now or just like with the remodel or if those are going away. And then under cabinet lights. So it's going to be the perfect trifecta. It's going to look fantastic. 3 forms of lighting in one room. Amazing. You can do your 3rd form of lighting can be lamps, right? It's simple. You can do a lot of different ways. So pendant, under cabinet lights. I'm going to show you how to do the under cabinet lights. It takes like a $50,000 kitchen remodel and makes it look like a $100,000 job. But just under cabinet lights are like backsplash and under cabinet lights. You just can't beat it. Every box has to have a wiring connector. They've got metallic and non-metallic both. Tool tight is the ticket. So whip that thing around, put your pliers on it, snug it up a little bit more. Boom, that's it. You know, I'm gonna use the laser on that one because it's important. It's got to be dead center on that window. All right, 2 types of connectors. Like I said, I'm going to take this one out, use a pop-in connector. That is what I'm going to need to do because the double wide framing member, my knockout and my connector are going to fall on the framing member. So I'm going to have to chew out a little bit and get this slipped in there and keep it flush as possible. You've got to watch out for your box fill. Box fill in a pancake box is pretty tight because it's only 6 cubic inches. So check your tables in the code. Every time you use a metal electrical box, it's got to have a grounding element to it. Most boxes have a 1032 green ground screw. Pop that sucker in there. Take the ground wire, and there's always, man, you get 7 electricians in a room, you have 10 opinions. It's crazy. Like, most of us are just going to complain about how complex the National Electrical Code is, and man, it makes it hard to do business. You know, it's nice that it's a trade that's protected by the licensing and permitting, right? It's good for something that's potentially this hazardous to have a barrier to entry. However, the complexity of the National Electrical Code is not serving small business owners. It wasn't intended to, I get that, but it doesn't. So I'm gonna tuck that up there. That box has a home run in it, which is going to be capped. This will not be energized. This is not a convenient place to put construction lighting. This switch, you know, we're just going to go ahead and energize that 3-way between the doorways and put our construction lighting in the can lights, and that's going to be good. So while I'm up here, I'm going to staple this into place. Within 12 inches of the box, measured along the length of the wire, not exceeding 18 inches. But that does differ depending on the code cycle you're on, what your jurisdiction has adopted. May not be a universal principle. Hello. So what we're doing out of our 2-gang box over there, respecting box fill, is we're adding a 4-inch square J box with a clear label, kitchen lighting circuit hot.
up high in the attic, out of the way of insulation, because this house is not that big. It's probably 1,000, 1,200 square foot tops on this whole floor. And if we, while this is opened up, get a good lighting circuit up here, we can easily pick up the entire main floor lighting load. That's like probably like 7 or 8 fixtures. And with LED light bulbs, that's hardly anything. So we're gonna put that up there for provisional. So when they call us in the future and say, hey, could you rewire my entire house? Like, boom, yeah, the circuit is waiting up there for us, right? Always plan for the next guy. He might be you. Sometimes people make fun of me for my hole on the end of my index finger. That really helps. It gets your electrical tape started. Man, you might suffer a cut there, but I've got a lot of surface area covered. Come on, guys. All right, so I'm gonna be running the under cabinet lighting here. And what I want is to stub out the under cabinet light, 2 locations, 1, 2. The lights are going on either side of the window and the sink. I need to gather this dimension, which is not provided to me, but it's 18 1/4 plus 1 1/4, which is the countertop, plus 30 1/2, which is the cabinet, plus 4, which is the toe kick portion of the cabinet. That totals up to 54 inches. I'm not gonna stub right at 54 because I wanna come in the bottom rail of the upper cabinet, and I wanna even err on the side of being just a little bit above that. The cabinet installer is then going to drill a hole through the bottom rail and bring my wire in and through. So I'm gonna bring 54 3/4 inch off the floor is where I stub out my conductors. 1, 2. Under cabinet lights, dude, it's like the best way of upping the dollars on your kitchen and making it look fantastic. Those little fit and finish details are worth so much. So what I'm doing, I'm pulling off my lighting circuit. I'm routing to a box, the location of which is strategic. I know that this is gonna land inside my sink base cabinet, so it's gonna remain permanently accessible. So I'm gonna pop that box in there. I'm gonna route a 14-2 from this box to the switch box. And I'm gonna tie it in to my I'm gonna tie it into a switch there. So this switch is gonna energize this switch leg, which brings this box live. Out of this box, I'm utilizing DC low voltage wiring. And so that's where this comes in. I'm gonna have 2 stubs hanging out of the wall about 12 inches. One's gonna run up here to 54 3/4, where I'm gonna leave it hanging out of the wall and clearly labeled. So when someone else encounters it, they know what the purpose is. And the other one, same thing, except I'm gonna hang it out of the wall on one end of the cabinet or the other, because this is a run of upper cabinets. And so I'm gonna have 2 zones that come live off of 1 switch, 1 power source, and 1 DC driver located in the sink base where it's permanently accessible. Some people will opt to put those on top of an upper cabinet or in the unfinished basement. I'm gonna put it right here because it's in perfect proximity to everything associated with the under cabinet lighting. It'll be relatively easy to find, I think. Guys, if you don't do this now and you decide later to do it, right now, it's 25 minutes and 15 bucks in materials. Later, it's headaches and cutting and fishing and probably 4 hours and 20 bucks in materials. Like, it's a headache. Now, right now. Stop the video and go do it right now. All right. If your wire is not rated, the jacket, the insulation, right? If it's not rated to 130 volts, it should not be in this electrical junction box, because AC and DC conductors can be run together. This is going to be a DC conductor because it's on the DC side, the lighting side of the driver. People confuse transformer and driver, right? Transformer transforms from one voltage to another voltage. Driver transforms from AC to DC plus changes the voltage almost universally. So this is going to be a like an 18 volt DC lighting system. If it doesn't have at least a 130 volt jacket, it cannot go in the box. It's not printed. The voltage isn't printed on this, and it's just a loose, it's not on a spool, it's just a loose bundle. So I'm gonna keep it outside of the box, slip it down the wall here, and bring it in just above the box, right there, 12 inches. And then I'm gonna route to where I'm going. Now what I can do is I can route it through here with the plumbing and the electrical in our jurisdiction. Some inspectors might have a little bit, no, everything's got to have its own bored hole through framing, right? In this case, the cable and this little 2-conductor cable are not contained within the same box. It's not requiring, just because it's in the wall cavity, to be of the same voltage, right? So I'm clear there. Let's bring it up here. Let's see where 53 and 3/4, 55 puts us. Rather be a little high than a little low. It's here-ish. Make a nice V mark I won't miss over here. So what I'm gonna do, I'm just gonna bend it over like that, put a staple there, not right at the edge. I wanna give the next person a little bit of flexibility. Put it right there. I'm gonna take some white tape and label that. All right, so we know what that is. It's right where it needs to be. I won't staple it up till I get the second one in here. All right, now what am I doing with this switch box? Well, it's pretty easy. It's actually super easy. All of my whites are neutrals in this case, so I'm gonna strip them all, put a wire nut on them, boom, done. I've got switch leg number 1, switch leg number 2. All my grounds are grounds and are combined together. I'm gonna leave 2 leads coming off my grounds, kind of like that, once they're combined. 1 for each switch, and then these are all hots. I've got the home run in, hot pass number 1, hot pass number 2, and I'm gonna jump from switch 1 to switch 2. So both switches get a hot, a switch leg, and a ground, and we're done. What a lot of guys do, which is mind-boggling, they omit grounding their switches. That's a code violation. All right, everything's pre-twisted, everything's of the same length, everything's stripped to the proper length, and now I've got a nice red wire nut to combine it all. I'm gonna tuck it to the back out of my way, give it a tug test, everything's sound. Tug test, good. Switch legs are not going to be energized. I'm just going to push those 1 to each side of the box. Won't be energized for now. Hots are done. I've got length to connect 2 devices right there, or add a pigtail or 2. I'm going to tuck that away. And now my grounds. There's more than one way of doing this, but I've got ample space to connect 2 switches right there. I've minimized number of junctions. Some people will be like, that's crap, that looks terrible. It's like, but show me where it's a code violation, and please admit that it does reduce the number of potential failure points. Okay, there we go. All right, again, tuck it way back, keep everything safe. Wires inside the wall.
We're in the basement at the electrical panel. We landed 5 circuits today, 2 at the bottom, 2 here, 1 up here. Now that we have this done, we'll move upstairs to do the kitchen cans.
We've got everything landed in the electrical panel, and now we're ready to do the lighting up here. Okay, so the pendant above the sink and the under cabinet lighting, boom, done. We saw that take place. But we've got 6 can lights and 2 pendants. These are gonna be centered on the windows. 2 can lights are in rows, 2 rows of 3. They're gonna provide great distribution of light throughout this kitchen. You're not gonna have any dark spots in this kitchen. You're gonna have 6 points of light plus the pendants, under cabinet, plus the oversint. Gorgeous, very well lit, particularly if there are light finishes in the space. Boom. So we had a single gang box here that went to an old pendant. We've got a switch leg that we're very suspicious of, so we're not going to utilize it. We don't know where it's going. We're not going to rip things open. We're just going to tuck it in the box, cap it off, and label it former pendant ? We can't just stuff it in the wall. It does come live when we turn the lighting circuit on, but we don't want to touch it because there's some funny biz going on there. So the 2 gang box, I cut in higher because I want to match all switches in this space to the same height. Unfortunately, that changes as soon as you get in the dining room, but we had to pick a standard, so we're making this room all the same. out of here, we're gonna have a hot feed in from above because it's all open, so we decided to bring our hot pass from the 2 gang to this 2 gang, and then we're gonna have 2 switch legs coming out, one to the 6 cans and one to these 2 pendants. I don't want to label things as you go. Coming back to label can cause confusions, and since this is my hot into the box, I've definitely got to be aware of that. I've got 2 switch legs. All cables into the box are not created equal in this case. I've got to distinguish this one. I'm going to do a black flag. Bring it through here. All right, that's my hot. I'm bringing it in the left side of the box here because I want my first. Don't you guys love it? I'm just thinking out loud here. Okay, I want my first switch into the room to be can lights, and my second switch to be pendant. So that's pendant. That spot is reserved for can lights. Knock out that one as well. My hot, I'll bring it right through there. And this is my extra set of conductors that are just to be capped off. That gets capped off because in this case, it's not actually a neutral, it's a hot or a switch leg. That gets capped off. These 3 together get pulled out of the way and create a label for them. Ready for the label, go on. Gets tucked out of the way. Okay, that's obsolete, but it's got to go in a J box. We have the capacity in this box for it. All right, all 3 of these are neutrals. We go ahead and make them up. Not incorrect, but possibly wasting your breath. Is that what I'm hearing?
So when you started with the number 2, I assumed you meant square.
You know what I'm going to do? This one's not doing anything down here, this mounting flap. So I'm going to harvest that material and just throw it in my parts box. And what I'm gonna do is put a screw through there. What I don't wanna do is penetrate the side of the box with a mounting screw into framing. That's a violation. But if I'm using the mounting hole of the box, I'm putting a drywall screw into framing. I think that's a pretty legitimate practice. So at this point, we're just in and out of can lights, right? We've used the laser, we've dialed it in, we know where our marks are. I've got first can light terminated. I've got my jumper to my second can light. Coming over here to Cliff. I'm gonna leave him plenty to make up in his junction box and terminate it nicely. Staple it up. Okay, I don't want to lose track of that. Every time I drop it, I'm gonna walk down the ladder, pick it up off the floor. It's gonna wear you out. I'm gonna take the twist out of it, give it a little extra, tuck it right in there. While I'm waiting on Cliff to dial in his...
We're 3/16
longer. Okay, so we're 92 and 3/16.
Yes.
So we're 46 and 3/32.
Which probably isn't going to matter that much.
Woo!
I should measure to can, not to wall, right? So I'm here.
For the pendants?
Oh.
Something different?
Tricked me into putting my can the wrong way.
As far as J boxes? Okay, so what Cliff's talking about is he's kind of just tucked up tight against the wall, but center of can is what we're measuring to, right? And the can is got marks, 1, 2, 3, 4. So we're measuring the center utilizing the marks here. You'll notice that one side of the can is bigger than the other, but the J box doesn't change center. right? So we're measuring to center, and the J-box is just oriented in the more convenient position. Right now, I'm gonna put it towards me like that, right? Matter of convenience. You can shorten the can. See these marks right here? You're gonna shorten the legs. If you are in a situation where your frame is not 16 on center, you see this will go out to about 24 on center. It's naturally designed for a nice fit at 16 on center, but if you've got to dial it down to maybe 12 on center, you literally just break it at these marks here and shorten it up and it collapses. And you can take it all the way down to, 6 inches, the width of the can. So let's talk through making up this can as soon as I find the center of it. And
I'm not sure how you're going to get that up there.
I'm gonna do my very best.
that's going to be 46 and 3/32 off the edge of the can there to the center of this can, which is going to be tight to the wall and 3.5 off the framing. And let's double check it, measuring the other direction. Yep, 3.5 off framing to center. So I'm going to put it in this space. And Cliff, this mark is yours from the laser, correct?
Correct.
All right. Use a hammer or screws. Cans provided with nails. To mount it, definitely use all 4 mounting. You want to get it. A can's relatively easy to actually get cocked, so you want to either measure or eyeball. What you can do, like in this case, we've got a mark on both sides, so I can literally just slide the can over, dial it in, make sure it's flush, bottom of can, bottom of framing, and pound that in. My can doesn't go over there, but I just did that to dial it into the marks. My can goes right there. Now I'm going to tighten it up in place. 46 and 3/32. Okay, well, that's right there. It's perfect. It's perfect. I'm like literally plus minus a 32nd of an inch. I can't go any further, but I don't need to. All right, pop the J-box off. Promptly throw the instructions in the trash, although there's probably something helpful in there. Use a small flathead screwdriver to pop these out. You can also, this is the integrated clamps, although you can also use standard Romex connectors in the round KOs. I'm going to pull these out of my way, bring my conductors in. Now be mindful, they're just like electrical outlet boxes for receptacles and things of that nature. Box fill applies here too, and that will be contained in the instructions. How many cables and of what size can enter this J-box? Okay, minimum of 1/4 inch of outside jacket into the box. Use the right strip gauge on your conductor so you don't damage the copper. Strip everything back about 3/4 of an inch. I love the pre-twist, although that's not code. If an electrical installation is going to fail, it's going to fail at the junctions 95, 98, 99% of the time. So I'm going to make those really good. I'm going to match the ends. I'm going to twist to the right because that's the direction the wire nut goes on. You can also use Wagos if you're a beginner or you think it's maybe faster for you. They cost 8 times as much. However, there's a labor savings, I'll give you that much. But is it worth it, right? Is it worth it? Maybe. All right, now you take your black conductor from the can, you match the ends. That stranded conductor is the one that's going to want to pull out. So you've got to really make sure that stranded conductor stays in there, fully seats in the wire nut, and then give it a tug test. This is where the Wagos can be really helpful. A 3-terminal Wago lever nut, because that little stranded conductor is going to be seated in its own little terminal. And I'm going to take that, again, that stranded conductor, I'm going to match the ends. I'm going to twist to the right, put my wire nut on, righty-tighty. Give it a tug test, all is well. I'm going to fold all of these together into the can. Junction box. My tabs seat in right there, boom. slide it back over where it was. Phillips screwdriver to snug it down. It's gonna have 2 set screws to keep it in place. 1, 2. And then you got to do the staples. Leave yourself a service loop. An M cable needs to be stapled depending on what version of the code you're on. Either 12 inches from the box and either 12 inches measure along the length of the wire or 18. Know your local codes and standards. It's never a bad thing to do a walkthrough with your inspector first. If you're uncertain, ask them questions. They love giving advice, typically. We got a little service loop. And then from staple to staple, we have every 4.5 feet along the length of the wire. It's got to be secured. So right here, we're probably 36 inches. We're good. Back in the medieval days when electricity first came around, these were the staples that were utilized. Look at that thing. That's just a raw hunk of iron ore straight from the earth, bent and pounded into shape. That's the modern staple. Pretty cool, a little taste of history. So Cliff's up in the attic. We've got to get a 3-wire down to this. Something I forgot when we were talking about it earlier. And so I'm giving him a nice bright light in the wall. He's looking through a decent hole, has a set of fish sticks, and he's gonna send it right down to the opening in the box. Voila, as they say en France. All right, Cliff, it's wide open. Pull it up a little bit. Up and there, I got it. Are you tied on yet? Just leave a little extra up there, I'm good. Thanks, Cliff. So this is what you call a dead end 3-way. See, this white is not a neutral. It's going to be remarked at its termination. The white is not neutral. The white is a hot to the common on the 3-way, and then it bounces back over 2 travelers to the other 3-way switch over there. That doesn't make any sense to you if you don't know 3-ways, but I'm going to show you that on the finish out. So for now, we're going to ignore the red conductor. Just cap it, push it out of the way. This is a temporary switch for construction power. That's all it is. Can switch is going to go in the middle. If you don't like that, let me know why. Because you see this first switch is bottom of the basement stairs, middle switch can lights for the kitchen, and the right switch is nothing. It's just a provision to the attic for future. Number 1 Robertson square drive. Boom. I'm going to tape up these devices because they are in a metal box, and it's possible the drywaller will actually back him out of the wall a little bit when he's doing his patch and repair. I just want there to be less for him to bump into. All right, so do 3 wraps of electrical tape as a temporary insulator. And I got to get a clamp in there next. I mean, that was really goofy. So when one of our team members walks up and they see the black flag on the white, and they see that it's a dead-ended 3-way here, they'll know exactly how to make it up. It'll be nicely and clearly labeled. Boom. So it's the end of the day. We're worn out, but we got receptacles in to code. Dedicated 20 amp circuits. We've got under cabinet lighting roughed in. We've got overhead can lighting roughed in. We're 100% at this point. The next steps on the project are fire caulk, inspection, insulation, drywall, paint, floor, cabinets, and then we come back. All right, so the rough-in is complete. The rough-in is the complete electrical that is behind the walls. No finished materials are installed at this point, so we've got to wait on grade-in to call us back out. And when we come back out, we'll be doing the finish out. That's receptacles and plates. But for now, we've got temporary construction light. All 6 can lights are in. 3 pendants. Our receptacle, GFCI for temporary power is required. That's in, tested. We verified, walked through, we've taken our completion photos of everything that lies behind the walls. It's so important. You never know when you're going to need that critical piece of information. Something gets damaged. And if you stick around, we'll tell you what it all costs and what you can expect to pay a contractor if you hire it out.